Dear all, hello and welcome to Simplified Triple Studies. In this session, I am going to discuss a simple project, namely design and development of solar steel based micro hydro power generation. Moving on to the discussion, the domain of this project is basically renewable energy source. Here, we are going to develop a prototype of solar steel based micro hydro power generation system. The major application is rural electrification as well as the drinking water availability, because many of the countries are suffering the scarcity of pure water, fresh water. So this is one of the another solution for the issue of fresh water unavailability. The overview of presentation is given below. First of all, I would like to discuss about the importance of solar steel based micro hydropower generation. Later, the system description. Then I am going to discuss the design procedure of this particular project. Then I would like to show you the hardware which I made. Later, the important test results and the discussion. Afterwards, conclusion. And I would like to highlight the references which I referred for completion of this project. As everybody know that the fresh water availability is one of the main challenge nowadays all over the globe. If you look at in your village also, some area there are a lot of scarcity of fresh water. Water is available, that is true. But what about fresh water? Everybody is getting accessible to fresh water or not? Are they getting fresh water? That's a big question. Almost 2.5% is available. The availability of fresh water is only 2.5%. That is another thing. Among 2.5%, the quantity is declining day by day because of the human activity. The freshwater availability is also getting declined day by day. Moreover, the electricity demand exceeds the supply. That means the installed capacity of India is almost 403 gigawatts as on June 2020. There are a lot of power plants, but the supply and demand is not matching. Still, there are scarcity of electric power. There are solutions for implementing new power plant and microgrid, but the location also matters a lot. Economic consideration, location, everything matters a lot. So the issues and challenges of implementing a new power plant is another a challenging fact, because location, then transmitting new lines to the particular location, economic viability, government policy, everything matters a lot. To overcome this issue, we need to find out a viable solution. There are a lot of viable solutions available, but we would like to propose a system which is a hybrid combination of solar steel and micro hydropower system. So that is the thing which we are going to explain today. And the similar kind of projects can be implemented for your academic project as well. You can modify. I will tell you what are the modification you can make out. Moving further, I am motivated by seeing this picture. The first case, there are water, but what about fresh water? There are muddy water. So, but we cannot use. Here some villages I have taken from the picture. I have received from Google image only. So here there is a issue with the fresh water. The third diagram depicts we are not accessible with the electricity, especially in some villages. Okay, you can see the candle lamp. Nearby there is an incandescent lamp. What does it mean? So we cannot access electricity in some village. That is another issue. Then if you are using the conventional sources of energy, there are bulk amount of pollution that will be impacting to the environment definitely. Also, the fossil fuel availability is depleting day by day. Surely we need to switch over from conventional to non-conventional source of energy. The last diagram, that is a really motivation. We need to switch over the conventional sources from conventional to non-conventional sources such as solar, wind, biomass, small hydro, etc. So this is the main motivation of the work. And we are going to propose a method called solar still based micro hydropower generation system that can be used as a project in your village. You can make out a small project in your village, right? To identify the issues of existing system, I have made a few literature and I have collected through some standard journals and found out what are the difficulty or what are the challenges of the existing system. You know, diesel power generation, that is one of the solution. It will act as a peak power plants. Okay. Why it is not base power plant means the generation cost is very high, around rupees 9 per kilowatt hour. Also, that is not viable every time because that is also leading pollution. Diesel is a part of a fossil fuel. It is one form of the fossil fuel. The availability of diesel is also getting declined day by day. Also, if I inspect the desalination plants, the operating cost is very much high in case of desalination plant. Surely, we require some other solution because technology is growing day by day. Obviously, we need to find out some other solution. And I found that there are certain difficulties for implementing microgrid in remote areas because of geographic location, government policies, and the cooperation with the people, those who are residing over there. Then many are not uh, aware about the importance of electricity, power generation. Okay, so these things also matters a lot. Definitely implement. It is a good idea only implementing microgrid. There are so many research are going on, but there are difficulties. Then among solar still, there are different varieties of designs are available. In this project, we are going to select which is the optimum design of solar still. So these are the few literature I have gone through that. Also, I have read over 30 papers I have read, especially standard journals. From that, I made this kind of conclusion. This is just for your information. Anyway, you can carry out the similar kind of project in your academics. That's why I just wanted to highlight it. These are the things which I made out. So that will motivate you. That will help you to identify your own idea. The block diagram of proposed system is shown in the slide. The components of proposed systems are, we have solar still, then there is a storage tank, then there is a gate valve, or just like a switch, just like a valve, a control unit. We have water turbine, then AC generator, then we have the control unit. So here, the control unit is based on microcontroller based units, the digital control unit. Here we are using AVR microcontroller, AVR Atmega 32 microcontroller. So these are the major components which are included in our system. Solar still is the major component. The major processes which are involved in solar stills are evaporation and condensation. The distilled water will be collected in the storage tank. The water which is not at all using, that will be directly passing through the gate or valve. It will act as a controller unit, and using that particular control unit, the water flows through the water turbine with a certain height. There are different water turbines like Pelton wheel, Kaplan wheel, Francis turbine. Here we need to choose Pelton wheel only. I'll tell you the reason why we have chosen Pelton wheel. Then the turbine is coupled with the alternator. Alternator converts the mechanical energy to electrical energy. So we can make use of those electrical energy. To make the smooth control, we have a microcontroller unit. The temperature is measured with the help of LM35. Water level sensor is also there to check the desired height of the water, desired level of water. Then we have TDS sensor also. So these informations are collected from the solar still, and that will be given to microcontroller. Then microcontroller gives the signal to operate the solar still. So there is a closed loop control which will be acting on this particular segments. The different parameters like temperature, water level, then the TDS, total dissolved salt, the amount of contents present in the water, Everything is available. Everything is displayed with the help of a liquid crystal display. There is an LCD unit which is connected to the microcontroller. So we made the coding on the microcontroller. So by deciding the variables, declaring the variables, and we made a coding. If necessary, we'll share the coding. If you require the particular codes, please contact us. Next, we have LCD display. This is your entire block diagram of micro hydro power generation. So moving further, as you can see, solar steel is the heart of this particular solar steel based micro hydro power generation system. We have saline water. Saline water will be directly connected to the segment which I given to the portion. We have a glass plate. There is a basin area. The major process involved in this particular solar steel is condensation and evaporation. So after evaporation, the condensation takes place. It depends on the temperature. So mainly depends on the temperature. That means useful heat. Then the water droplets will be collected at this particular tank, which is kept at the lower side. So the water will be distilled. Then water purification will be taken place. Okay. So the glass plate, which is kept over here, also there are mirrors to improve the efficiency. Here there are certain mirrors. So that gives more intense heat energy. So the process will be getting improved. So solar steel is the major component. Now I would like to show you the design procedure of micro hydro power generation. So first of all, we have to focus on the physical design of solar steel. So I already explained the principle of solar steel. Here the material, we can see the glass, then there are mirrors, then there is a metal basin, and you can see the way where is the incoming of the water and the outgoing of the water. And if you look at the basin area, the basin area we have chosen is 73 into 73 mm square, 73 into 73. It will be meter square only. The angle between basin and glass has been selected in between 32 degree to 45 degree. As far as our location concerned, we are chosen as 40 degree. So based on the azimuth angle where the sunrise is available, according to that we have chosen. And the turbine is installed 15 meter above from the basin area. At least we can apply it for a running river nearby the mountain area, or you can easily install. At least the height should be 15 meter to get the desired amount of power. The total hydropower you can compute using the formula P is equal to M into G into H net into efficiency. M is the mass. Anyway, mass is water body. You have to calculate the mass of water body. G is the acceleration due to gravity. H net is the head loss, and eta is the efficiency of the system. So efficiency of the system we computed as 75%. Then the net head loss you can calculate by computing the gross head into 90%, 0.9. All right. So by using this, you can estimate what could be the total power which can generate from the micro hydro power generation. Okay, this equation is very essential for computing the total power generation. Later on, what we have done is we have scaled down the entire parameter into very lower scale. Okay, it's less than very tiny, very compact, because we have some limitation to implement it for big project. Okay, we have some certain limitations. So we made a prototype just for the testing purpose. Here you can see there is a solar steel, and you can see the temperature sensor LM35. We have TDS sensor, and to make the smooth control, we are having Arduino Uno at Mega 32. We have AC generator. Then we have the Pelton wheel. All those things you can purchase from online website and eBay, or you can go for RoboKits. Any of the website you can check it up and purchase. And also it's available in the local shop also. You can visit once, and you can, before going there, you make a list. According to that, you can plan. So these are the prototype which we developed, and we have carried out the real-time testing as well. Okay, but the power level we are getting in terms of milliwatts only, because the scale of production is too lower scale we made out just for the validation. Okay, we haven't done for it for here a big project. Why? Because funding consideration, all those things are required. Anyway, we are going to apply for that. Then we have carried out that real-time testing. The table shows the test results of solar steel-based micro hydro power generation or power system. We have started the testing at 11 a.m. and up to 6 p.m. we have conducted the testing. The quantity which the parameters or the variable which we observed are: number one, quantity of water purified, because water purification is also matters a lot. That is also one part of the project. Then amount of power generated in terms of milliwatts. Later we plotted the quantity of water purified versus the hours, the duration. So like we have maintained the duration into 7 segments, and we found that in between 2 p.m. to 3 p.m. we could make the water purification at the maximum level. Why? Because at that time temperature is very much high. So as the temperature comes down, the purification rate also has been reduced. These are the basic observation which we could make out. Table 2 says that what is the relation between temperature with respect to the quantity of water purified and the amount of power generated. Temperature is also another important parameters. First graph shows that the power generated versus the number of hours. In this context, we can understand that at a fourth hour in the sense around 2 to 3 p.m., the maximum amount of power has been generated. You can see here. At this point, maximum amount of power has been generated. You can calculate the average amount of power also. You can calculate what could be the average amount of power, around 48 milliwatts. It's a minute, small scale only. That's why I'm telling about milliwatts. Also, the quantity of water purified, that is also depending on the temperature. See, the graph shows that as the temperature increases, the quantity of water purified in terms of milliliter, that is also getting improved. That is also getting increased. Both are in the same proportional, directly proportional, you can say. Also some variations, obviously there are certain variations. That is why there is a declination in the graph. Obviously, the solar energy has intermittent in nature. It's not permanent. It's not continuous. Okay, it's a permanent only, but it's not continuous. There are intermittents. There are uncertainty. Weather dependent, weather will be changing. Okay. Then amount of power generated versus temperature. That is also in a direct relation. Okay. So these are the things which I obtained after doing the real-time testing. You can do similar kind of project and think for the improvement. Okay. What we have done is we have developed the hardware project of solar steel-based micro power generation system. Then we found out the main variables: the hours, the temperature, quantity of water purified, and the amount of power generated. And we have plotted the respective graphs. So that I have mentioned here. The efficiency we computed as almost 75%. Still, there is a future scope for improving the efficiency. You can go ahead with improving the efficiency. Fine. I have referred the following journals and conference papers for gathering the information to understand the problems of existing system, to think what I can do. You people also can go through these references. Better find out the recent latest trends so that you will understand what is happening right now, what you can do. If you are having any questions, please put up in the comment box. So we are happy to reply. So I have done this project with the help of my students and my guide. So let me know if you are having any further queries. We are very happy to answer that. Thank you for listening this video. If it is useful, kindly share with your friends, and happy learning.